We learned how weather and climate are different. Weather is something that happens day after day, and even in a normal climate, before we started emitting all these greenhouse gases, you could have a very strong snowstorm or a very strong cyclone and very heavy rain and so on and so forth. And we said climate is when it's averaged weather over many years. Now you're asking me, well, if climate is changing, will weather also change? We already said this a little bit. Yes, so you can see a hat blowing away here and an umbrella blowing away and a dog getting knocked off his feet. And now the forecast for the coming century says in most places the temperature will rise by between 1 to 4 degrees. Dry regions will become drier and wet regions will become wetter. The hurricane season will be longer because warm waters are needed for hurricanes and cyclones, and if spring comes earlier and winter comes later, then you have longer season of warm water. So hurricane season is likely to get longer, and the hurricanes will be bigger, and they may also turn up in unexpected places because oceans are warming and expanding in the warm waters to higher latitudes, and the hurricanes have more energy from the warm ocean, and they can grow and grow and grow bigger and bring more rain. With sea level rise, they can bring more water onto land and so on. On all continents except Antarctica, there will be a greater chance of heat waves. In fact, in 2023 there was a heat wave on Antarctica as well. Of course, Arctic is getting many heat waves these days, and the heat waves will last longer. There will be more heat waves and they will last longer. There will be periods of serious drought in some places, but also periods of heavy rain and floods and crop damages and life disrupted and people getting washed away and so on. And bad weather will involve more powerful gusts of wind and more thunderstorms and bigger hailstones. Is this only something in the future? Not at all. Already global warming has reached about 1.4 degrees centigrade compared to the 1850 temperatures. 1.4 degrees warmer compared to 1850. So in the last 20 years, 30 years, there are evidences of more heat waves, longer lasting heat waves, larger heat waves and so on already. But in the meantime, I have a phone call I have to take, so give me a second. When a delivery comes and the delivery man calls and says you have a package that you have to collect, then I have to stop the podcast. And fortunately, this software that I'm using to record the podcast allows me to pause and start. But you can see in the podcast that I paused and restarted. It's okay, right? So already we can see in many places that heat waves have become more frequent or more intense or larger in scale, and rain has become more heavy or rain has become less, and droughts are coming more often, and so on and so forth. Okay, so weather forecasts have to be taken with a pinch of salt though. Why? Because predicting climate is even trickier than predicting weather. That's why these predictions are based on the calculations of thousands of computers, which is unfortunately using a lot of energy as well, so you have to be careful. These predict, for example, that the drier regions will become drier, desert will get even drier, a region that doesn't get much rain may get even less rain, and the wet ones will get wetter, which means the region that's getting a lot of rain will get much more rain. And this happens because of the higher temperatures overall in regions where it is already dry. The last few drops of water will evaporate, and so it will become even drier. The warm atmosphere is thirsty atmosphere, so it will suck up every drop of water from the soil, from the river, from the lake, from the glacier, and so on and so forth, right? So in regions that are wet, more water will evaporate as well. This means that there will be more water in the air, and it will also rain more. Hurricanes are big tropical storms that can do enormous damage. They can kill people, uproot buildings, and destroy roads, and so on. Climate change could make them bigger, and they could happen in more and more places because warm waters will spread into more and more places, especially higher latitudes. Hurricanes require a water temperature of at least 26 degrees centigrade in the ocean. Warmer the water, the more easily they develop the cyclones, and stronger they can get, and faster they can get stronger. So you see them mainly at the end of the summer in tropical regions, but the seawater is warming up and the currents are changing. That's how in 2017 there was a hurricane heading for Europe. Usually not many hurricanes go in that direction. They are born in the tropical regions, let's say near Africa, and they go northwest into the Gulf of Mexico, into US, sometimes turn around and die in the ocean, but sometimes they survive all the way to Europe. The name of the hurricane that headed into Europe was Ophelia. Fortunately, Ophelia weakened a little before hitting land in Ireland. She still caused torrential rains and wind speeds up to 150 kilometers an hour. That's a very, very powerful wind gust. The storms resulted in at least 5 deaths and millions of dollars worth of damage. And Ireland is not at all used to hurricanes. Scientists are still arguing about whether global warming is going to mean more hurricanes or not, but the hurricanes that do get born will probably be stronger because of the warm waters and warm temperatures in the air on average, and like Ophelia, sometimes happen in strange, unexpected places. So you have cold air and warm air that can mix, and then wild things can happen, and you have circulations, warm air going up, expanding, cooling, condensing, and sinking, and again forming icicles and hailstorms and so on. Hurricanes and other storms can be more violent because the warmer air contains more water vapor. This means that the showers that fall are often worse. How does that happen? For water to evaporate, heat is required. Of course, this heat is released when the steam or the water vapor turns back into drops of water. This is exactly what happens in clouds. Clouds develop because water vapor cools and drops of water form. As a result, the air inside the cloud warms up because the condensing water is releasing the latent heat of condensation, if you know what that means. Otherwise, don't worry about it. And cloud air is warmer than the surrounding air. This allows the clouds to keep floating along like a hot air balloon. With more water vapor in the air, the cloud can become even warmer. It means that it goes higher, just like a hot air balloon does when the balloonist heats the air inside, and the higher the cloud, the more violent the weather, because the temperature contrast from the outside to the inside is very strong. Inside a cloud, particles are constantly whizzing past one another. Warm air rises, cold air sinks, as we see here. Higher the cloud, the faster this happens. It's a sort of a vertical wind. You are used to winds coming horizontally, but you have also vertical winds. Just like in the ocean, you have vertical currents when the water sinks. So drops of water hitch a ride on these currents of air up and down. The little drops that are formed are not heavy enough to fall. They drift back up and grow, and when they collide with each other as drops of water, they coalesce and become bigger. When they are heavy enough, they finally fall. So warm air produces both higher clouds and heavier showers. The physics is very complicated, but we are trying hard to understand these. And then you get these thunderstorms with lightning and thunder. Thunderstorms develop because the drops of water freeze and ice crystals form. It's very cold up there. When ice crystals rub against one another, they create electric charges, like when you rub a balloon over a woolen sweater and you hear this crackling sound and sparks. The harder you rub, the more it crackles. The same way, a bigger electric charge in the ground creates more serious storms. Hail develops also because of the air currents in the cloud. Cloud drops of water climb into the cloud where it's even colder, and the drops of water collide with ice crystals together. They're heavier and they can sink deeper into the clouds, form there, and they rise again, growing in size because of this constant collision with other molecules, and this continues until the hailstone is too heavy to remain inside a cloud. Its gravity, its weight is so heavy that gravity pulls it down. Then it plunges to the ground at great speed. The higher the clouds are, the longer the hailstones continue to grow. This means that larger hailstones can fall in a warmer climate. The bigger they are, the harder and faster they fall. A hailstone the size of a tennis ball can easily get up to a speed of 120 kilometers an hour if it knocks you on the head. Hope it never does. It can create serious damage, if not kill you. Car windshields are blown out, and roofs of houses are torn through by hailstones, and so on and so forth. Okay, so this is going to conclude soon, but I want to keep this here. We'll add some more details of the climate impacts in the next podcast. And again, reminder, learn these things, be aware, but do not get scared, do not get anxious. Just use this knowledge to decide what you want to do about it. Okay, talk to your friends, talk to parents, talk to teachers, talk to neighbors, talk to siblings, and talk to strangers if they are safe and allowed to be talked to by your parents, and see what people are talking about, whether they believe it or not, whether they want to do something or not, and what can be done, and so on. We'll see later on. Okay, see you in the next podcast with a bit more about climate impact.